be doing something different. And yeah, I've always been curious with this question of whether an RNN or using a Markov chain. Okay, Markov chain is basically like given like a particular event, what's the probability of the next event? So like applied to text generation, it will be like given that the first letter is an A, what's the probability that the next letter is a B or C or D? So yeah, let's try out this from TensorFlow, this notebook called text generation with RNNs. Okay, so I've actually taken a step to download this Python notebook into my this is called Colab. So Colab actually helps to give you like some free resources to do it. Okay, so first let me just change my runtime to a GPU. Actually, this GPU is not exactly like given to you all the time. Like it may not be given to you because like yeah, it really depends on the dynamic allocation for Google. So yeah, best not to use this for your own models, but for a very short like testing, yeah, it works. I just a disclaimer, I haven't tested out this code yet. So let's see this tutorial demonstrate how to generate text. Okay, this is like the kind of text that they have. Okay, maybe later we can just use our own text. Okay, but right now we use this text here. So okay, let's just run whatever template model. Oh, run anyway. Yeah. So I guess this is the file that they want us to load. Okay, let me just see whether I can import this. Yeah, so we'll be running the Google notebook for this RNN. Then after that, I'll code my own Markov chain model, and then we see whether or not the results are the same, okay, or similar. So yeah, okay, let's take a look at the text then. Yeah, so let's go. Okay, so if let's say I want to print out the length of the text, how long is this? Okay, that's one. Oh yeah, they already printed out here. So text. Okay, let's just print out the whole text. Oops, I think I might have overloaded my. Oh, there we go. First citizen, blah 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 blah. Okay, so maybe we can see what's in this text. We can see what's the unique. Let's see, unique characters in string. Let's see how do we do this. I know, yeah. So in like Ruby, there's a unique. Oh, yeah. You can do a set, I guess. Yeah. Okay. All right. So let's see what are the unique characters. So it looks like, does it have the whole list of alphabets? Not exactly, actually. This doesn't have some of the small letters. Yeah, it's like, okay, maybe let's sort it so that we can, you know, okay. Da, da. Oops. Yeah. Okay, so I don't exactly want like it to be like that. So maybe I take away list. I don't know whether this would work. Hmm. I actually want to join everything together. Let's see what they did here. Yeah. Somehow once I do sorted, it becomes a list again. So I guess I will need to join this like that. Okay, then I don't really need this. I can just put this as a list. There we go. So A B C D E F G H I J. It looks like it has the entire alphabet here, entire list of capital letters here. Some symbols. I guess in Shakespeare's, this is a new line. I guess in Shakespeare's play, like he only uses exclamation mark. Why is there a dollar sign? Do you talk about money in there? I don't know, but I know in Julius Caesar time it's probably not a dollar, but yeah. And quotation marks is understandable because of speech, commas, dash. I guess Shakespeare uses dash for some words, dots, yeah, like full stop, semicolon. It's interesting that there's a tree over here because like that means like in Shakespeare's text, there's only a number three and the rest of the numbers don't appear. Yeah, so I guess in like my Markov model that I'll generate later, I will just ignore the number because like there's only going to be like one number. Yeah, I'm not sure whether that will be useful, but anyway, let's okay, good to know that the entire alphabet is represented here. Okay, so I'm still thinking or not whether I should use like capital and small letter to differentiate this. Oh, guess what? They already did the unique characters. Okay, I was like one step ahead, but yeah, but they didn't show the unique characters. So I guess this is like 65 characters. Yeah, I mean, this is 26 times 2, 52, plus this one. I think it's around there. Okay, so vectorize the text. Okay, what do we mean by this? We use the layer, can convert each character to a numeric ID. Okay. Okay, I guess it's like just split into the Unicode encodings. Okay, let's just see. Let's just see what's this. Okay, I guess this just means you convert each of these characters to a number. Yeah, I mean simply put, yeah. So that after that you can just invert this number and get the strings. Yeah, so this is just a way to do string lookup. But I guess another way to do it would be to just assign values based on the unique text that we saw here. This can be a 0, this can be a 1, this can be a 2, and so on. So later on you can use a string index to recover back the text. Okay, so you can see this character from IDs equals to this. Okay, then we can get back from this 40, 41, 42. We can get back A, B, C, D, E, F, G, which is like what we have put here. Okay, so this is just a way to encode it into like, it's just a way of indexing actually, yeah. And then we can return the text from string. Okay, this is basically just to do this whole operation at the top, reduce, join, whatever characters from ID that you decode from the RNN's output, and then you just join them back into a string. Okay, so let's see the prediction task. Given a character, what's the most probable next character? Okay, RNNs maintain an eternal state given all characters until this moment. Okay, let's see this. All right. So this is the first step to encode the entire text into like code. Okay, then after that, data set from tensor slices, which this basically just loads this ID into the data set. I'm just curious if they put this like that, then what's the test set? I guess the test set will be because you use the entire training set here, right? The entire text document is a training set. So I guess your test set will be your user input. Like you have to type some characters and it will print it out. Okay, so yeah, so this is like the first few texts. Yeah, let's try take 50, take 30. First citizen, before we proceed, I guess this is like the first, this one. Yeah, okay, sequence match. Okay, this is just giving the epoch, so like they loop over 100 characters to train. Okay, I'm not going to change most of this. I mean, I guess they already optimized this. So like first citizen, this is like you encode it. Okay, cars from ID, this is the character that we did earlier. Cars from ID is this one. Is using the string lookup to get your mask. Okay, and my string lookup has already been given the vocab here, and the vocab is given by the entire list of unique characters. So they already assign a number to each character. Okay, so that's what we need to do. Okay, next, if you join the tokens back to strings, you get this. I guess it's in batches of 100 characters. Yeah, because like over here the sequence length is 100, then we divide the string into 100. So this is like 100, you, then this is the next 100 characters in the text, and this is the next 100 characters, and so on. Yeah, I guess that's what I mean. After training, you need a data set of input label pairs. So basically what will happen is that this will be, okay, so I'm quite curious what is the input and target text. So let's take a look. Input, oh, wait a minute. No, I have to give it something. So like Okay, I guess they will show it later at the bottom. Let's just see what they do. So okay, the split input target will split TensorFlow. This will input will be all the way to the last character, and then the target text will be one. Okay, let me see what they do first. Okay, so this is, oh, I see what they are doing here. I see what they are doing here. Okay, so you are given the entire string here. You do until the very last character. Then your target text will be the next string. So like given T, my next target is E. Given E, my next target is N, and so on. So they are using like a temporal space to like do the characters. Okay, sequences dot map split input target. So we already have a list of sequences over here. So what we do is, yeah, you have sequences. Let me just see what are the sequences over here. Sequences. So I guess these sequences are basically this stuff here. Where was it? This is one sequence. This is a second sequence. This, like, they basically take the entire data set and split, okay, into like sequence length of 101. Sequence length plus 1. Okay. Okay, I mean it's important because like I just want to see how they train this. So with each sequence, okay, we map this. So each sequence will have its it will have it, the output prediction is basically the next character for that sequence. So let's see, for this input is like this, and the target will be like it's been sliced to the next one. Then after that, we take a training batches, okay, batch size of 64, and we do the sequences here. Okay, so yeah, these are just some stuff like you shuffle your data set, you prefetch the first one. Yeah, okay, so build the model. So there's embedding damage of 256, the RNN units, there 10. Wow, there's a lot of RNN units for this problem. Okay, yeah, I mean, sure, if that helps. So this is a GRU. Okay, let's run this. Okay, so basically the characters will go here, embedding, one character, two character, three character, four character, and then like after feeding in this to the states, the output will then be like the next character. Then this one supposedly will go into here and then come up. But in this case of pre-training, of training, we already give it the correct sequence here all the time, and then we just compare one by one, based on what is predicted here, how close it is to the supposed logic. Okay, so I guess hey, let's try to. Okay, so there are 64 batches. Yeah, came back 64. Each sequence is 100. Oh, that's interesting. I thought it's 101 because of the way they did this thing here. Let's see. I thought it was 101. Like here, sequence length 100. Hmm. I guess when they do this, I mean, it's quite easy. You can just print length sequence. Yeah, it's 101 here. So, oh, I know why. Because 101 is because the input will be the first 100 characters, and then the output will be the shifted 100 characters here. So it's 101 to cater for that. Okay, that makes sense. So there's like 100 units here in this RNN. Okay, so yeah, each of them is 100 for the example batch and for the input batch. Um, 64 batches, 100 characters each. And then the last number here is the vocabulary size, which is basically how many characters we have. Like over here, we have 66 unique characters. Okay, this is the model. Actually, it's quite a complicated model, but because TensorFlow has this GRU layer, you can just specify your units, and then like whether you return or not, return the states, which is basically return this state here, return sequences. Yep. Okay, so let's. Okay, don't want to delve too much into this because what I'm interested in is whether or not. because I read like blog posts of other people doing something similar, and then like I mean I haven't looked at the Markov implementation, but I think I've always wondered to myself like what's the benefit of an RNN? So let's see what's this. So it's like this. Okay, how do they what did they do here? Random dot category categorical example batch predictions num samples is 1. So we sample across the predictions, some indices, and then basically we just put the indices here in flatten the array, and then basically this is the input, and then the next character predictions, okay, will be like here, like text from ID sample indices. Okay, so like example batch predictions is in logits, I guess. So let me just print out and see what it is. Example batch predictions 0. So this should tell you the logits of all your characters. So there are 66 characters. So this should give you the like basically before passing it through a probability distribution, this should give me the okay, it's 166. This should give me like the amount I should expect for each of these characters. Yeah, you pass it through a softmax function and then you get the logics because the TensorFlow here returns this self.dance, this one. Yeah, I just wonder why they didn't like do like activation equals to softmax here. Okay, let's train this first and see whether it works first before I change this model. Okay, train the model using the sparse category cross entropy because it is a logits. You want to train to match the output logits. Okay, and then okay, use Adam optimizer. Okay, actually this is quite a good tutorial. I mean, yeah, so because your model returns logits, you need to set the from logits. So if you set from logits equals true, they will put the softmax here. Okay, if you put from logits equals false, you need to do the softmax yourself. Okay, before that. Okay, we don't really need this. Okay, yeah, 20 epochs. Okay, let's use 10 first. Okay, I mean I don't know how. Okay, then this is to train the model. So I wonder how long it will take to train the model. Okay, well, actually it's not too bad. Yeah, it's not too bad. Okay, but let's see after 10 epochs how good the training is. Okay, and then we will compare it to like an RNN and see whether it works better. Okay, wow, it works. Makes a single step prediction. I'm just reading through this. Okay, so there's a custom trading loop here. Okay, let's see how good the model is first before we see how whether or not to do the rest. So it's about like 10 seconds each. I guess it's about 1 minute worth. Yeah. So I guess to generate, you just basically take the you sample from the probability distributions here, and then you feed in this next word here, next letter here. You sample from the probability distributions here, and you feed in the next character again, and so on. This is like an RNN style generation until you reach like the end of file character. Okay, over here, I don't think we have an end of file character because like we didn't put it in the vocab. Okay, but you can just like generate X number of characters. Okay, later we test it out. Each time you call the model, you pass in some text and an internal state. Okay, the model runs a prediction for the next character and new state. So basically, the model state here, okay, will be passed down to the next model here. Okay, because we put like return state equals to true in the model itself. And then you just keep doing this feeding in to get the next state. Okay, the loss looks like it's down, but it's not fully down yet. Okay, let's see how it works. Okay, so you make a prediction. I wonder how long it will take to type this whole thing up. This looks quite a long and chunky code. Actually, I think it can be done much simpler. Yeah, I mean RNNs nowadays like much easier to code than this amount of code. So like over here we give it Romeo. Oh, actually it's not bad. Yeah, and then like the model just goes through model next step, next character, state equals to states. Okay, so basically your internal state here is taken from here. This will be your next state, internal state for RNN, and this will be the next character uh, that will be generated. Okay, one step model dot generate next step, and then later you feed in this again. So your one step model here, okay, it will probably when you call it generate one step, okay, it will basically use the predicted logics and sample from it, like here. Okay, and then you can get the next character. Okay, simple enough. All right, actually this is not too bad. Let's just try. I mean, you have any suggestions? You can just say also, but let's not use Romeo. Maybe like I am very tired. Okay, let's try generating this and see how good the have you respected mouth. Only get he had for serving it is Polish shit. I guess one good thing about Shakespeare text is that even if your word seems to be wrong, uh, it's Shakespeare. You see, I mean, he can spell stuff wrongly. I would to see the sky. Okay, let's try again. I mean, it is so I guess RNN they will take into account like all the previous like characters generated. Then yeah, so it's actually not too bad. Like you see, who was a poison age? Wow. So I'm quite curious to use this to generate music also. I mean, people have tried to use this kind of stuff to generate music. Interesting. Okay, let's see what's the if you want the model to generate text faster, you can use 5 and batch the text generation. Yeah, I mean it will be the same, I guess, because it's parallel processing. So you can see different predictions. Okay, this one I think we don't need all this. Let's delete all this. Export the generator. Customize training. Uses teacher forcing to prevent bad predictions from being. Okay, seen how to run manually. You want to implement curriculum learning. All right, so if you have custom training look like that, okay, it doesn't really like what does it mean by this curriculum learning? Like, did they even implement the curriculum learning here? Okay, it doesn't matter. Yeah. Oh, what happened? Implement. Okay, it doesn't matter. Yeah. Okay, I think that's the end for the RNN part. It's not too bad. Okay, now let me start coding. Okay, so let's do the generation of text using the Markov chain method. So firstly, what we need to do is let's see whether the text is still here. Okay, so this is the text that we have. Okay, so what I want to do is maybe we can do like what Claude Shannon did the last time. We can do is we can do a one letter prediction based on the previous n characters. So what we can do is like maybe you have a matrix of like A B A B A C. I mean, assuming it's two characters, and then like over here you can have the whole output dictionary, and then over here is like the probabilities, like the counts of each of the inputs. So like 0, 0, 0, and then like each time we go through the text, okay, and then we see based on the combinations of all this, okay, we will assign like a number to each of this. Okay, I mean maybe we can initialize this all at 0.01, I guess, so that like we will avoid the divide by zero error. So we just count. Okay, so the idea is very simple. Count the occurrences of the next character in sets of n plus 1 and update. Oh, it's very irritating, this thing. Can I delete away my combo thing? Tools. I'm not too sure how to delete it. Uh, Settings. I have no idea how to remove away the I have no idea how to remove away the combo thing. Yeah, it was okay, it doesn't matter. So update occurrences of next in a sets of n plus 1 characters and update the frequency matrix. Okay, then after that, when sampling, just sample the so irritating. Remove combo in collab. Tools preferences miscellaneous. Tools set power level to no power. Oh, so it's by power level, is it? Some power, no power. Okay, great. All right, so I think we can avoid the irritating things now. When sampling, just sample the next character. And sample um, the next character based on the first n, based on a lookup table of the first n characters. Okay, so it's simple enough. So, okay. Okay, something like that. Okay, didn't really look that great now because I put some stuff here which is not reflected. Okay, something like this. Okay, so what we want to do is, okay, we want to look through the entire text. Okay, for I in range, length text minus, okay, let's put like n, we let's call n equals to 2. Okay, so like n plus 1 characters will be here, so minus 2. Okay, so then we will do like okay, first we need to have unique characters, so maybe we can put like unique equals to set text. Okay, then we just join this. Actually, we don't need to join, we can just put like that. Unique equals to set text equals to list set text. So this will be like the list of unique characters, like this. Okay, so this will be the list of unique characters. I guess I can still put the dollar and the comp and the tree. So for I in range, then text. Okay, minus 2 prints text I plus n. Okay, so it should print out like, okay, so this one should be minus n minus 1. Okay, because we want to print out sets of 3. Okay, something's wrong, something's wrong. Okay, we printed out a bit too much. Okay, you just stop this process. So I want to print out like all sets of n plus 1 characters. Okay, so it's like this, like the fairness of, yeah, so basically out of these sets of 3, we'll put the first 2, okay, into like a dictionary. Okay, thereafter Okay, thereafter we will basically like check what is the next word based on the first two letters. Okay, so conceptually is simple, so maybe what we can do is like that. We put the dictionary is like this. Okay, right, so what we will do is D. Okay, text I is to I plus 2, I plus n. Okay, this chunk will go into the dictionary. Okay, and then we'll put this equals to, okay, we firstly need to initialize the dictionary. Okay, if it's there. So okay, if it's in dictionary, then no need to initialize. Otherwise, give it initial value. I guess I can see like why an RNN might be better already, because like RNN you don't have to do this kind of Markov chain method, which will be difficult to scale up. Like you do two characters already need such a huge array. Yeah, but like you want to do three or four characters, it will definitely take a long time to even scale it up. Okay. And it gets worse if the number of characters are very high. Okay, so something like this. If it's in dictionary, add one to the next character. Otherwise, give it the initial value. So one good thing about this is that with modern computers, we have a very large memory space, so we can do this kind of like brute force kind of solutions. So you can just do this equals to x tends to 0. Okay, so firstly let's test this out first. So what this should do, okay, let me do a code block. What this should do is give you like stuff like this. Okay, so if let's say we have like x, let's call this b. Okay, b x, okay, plus equals to 1. Okay, then we just print b. We should get everything as 0, and only like the b, where's the b, the small letter b. Oh, sorry, x. Yeah, x is 1. So this means that if the first character is like this set of characters, which is like whatever it may be, we just increment like a frequency of 1 to that character itself. Okay, so we do it like this. That particular, because the first n characters is I is to I plus n. Okay, so actually we repeat this text I plus n. So maybe what you can do is you can just have a reference equals to text I plus n. Okay, and then we just put if this reference is in this, and then this, and then maybe we can put reference next value text I plus n. Yeah, so that this will look neater. Otherwise, give it the initial values. So we can do it like that. Okay, and then hopefully this would give us a nice dictionary. Let's run it. Oh, that was fast. Okay, that was fast. Okay, let's see what's my D now. Okay, now this is a little slow. Okay, so maybe we just print maybe like D Okay, let's see the length of D first. Okay, 1403. That's not too bad. I mean, there's 1403 different possibilities. Okay, so let us print out maybe the, like, because we have Romeo, right? RO. So this should give us like M as the next possible one. So RO, the next followed by dot dot is 63, followed by M is 163, and so on. So this is the distribution that we have. Okay, maybe we just print this so that it will appear nicely in one line. So this is like the distribution of characters given a starting to. Okay, so what we want to do is we want to sample this. Okay, how do we sample this? So it means that we need to find out a way to basically convert this, okay, into a probability distribution. Okay, let's just define this. Define sample, okay, and then we put here is a input date. Okay, so maybe like this. For key value in input date items. Okay, so maybe you can put like value counts equals to this one, letter car array equals to this. Okay, car array plus equals to key, or character dot append key, and the value array value counts dot append value, return. Okay, so we need to sample the, so weighted sample. Okay, so we want to do this. I think it's dot categorical, I guess. A weighted version of random dot choice. List of candidates, number of items to pick, probability distribution. Yeah, random dot choices. Okay, we can use random dot choice, or we can use mp dot choice, I guess. Yeah, numpy dot choice, list of candidates, p equals probability distribution. Okay, let's do this. But I guess, they use categorical, right? So I guess this would work also. tf dot random dot categorical. So there must be a numpy version of it. Yeah, no, looks like there isn't. So it's a numpy dot random dot choice. Okay. Import numpy as mp. Okay. Over here, random dot choice. Okay. So the numpy dot random dot choice will be the list of choices, the size, and the probabilities. So it would be like this. The list of choices will be this. List of choice would be basically the car array. You draw one, and then the probabilities would be value counts. Okay, but of course this is not probability yet. Okay, I'm still thinking whether to make this a softmax, or we can just use like a frequencies approach and divide by the sum of it. Yeah, maybe we just divide by the sum of it. Yeah, something like that. We can just return this. Okay, so let's try sample DRO. Okay, unsupported operand types for list and ints. Okay. let me just print out the car array, and then we print out the value counts also, just to see what's going on in there. Car array is this thing, and the value counts is this. Actually looks correct. Unsupported operand types for list and ints. Okay, what's wrong? One D array like or int. I guess we need to like experiment a bit with this. mp.random.choice a b c. We draw one, and then we take the uh, value counts with like 0 0.2, 0 0.4, 0 0.4. Looks okay, right? I mean, looks like it can work. Unless, no, this doesn't work out. Oh, yeah, that's right. I cannot just divide my value counts by this. Okay, because this is not a numpy array. Yeah, it doesn't matter. We can just make it a numpy array, right? Okay. numpy.array append array and value. I can do this, okay, because numpy doesn't have an append like this. Yeah, we can either do this or we can just do the usual dictionary way, okay, and then we could just like convert this to a numpy array, so it's like this, so that we can do overloading. Okay, so this is the truth value for the array. Okay, return mp.choice. Okay, the truth value of an array with more than one element is ambiguous. Okay, I mean, I don't get why this is an issue at all, but let's suppose we do it like this: 1 divided by 66. Suppose we do it like this. Yeah, this will give you equal probabilities. So somehow this and this doesn't work out. Like, I don't know. Let's see the shape of this. 65. Maybe because of this. Like, if I flatten it, I mean, this works out fine, but then this thing doesn't. I have no idea why this doesn't work. Maybe we need to put it back to a list again. Yeah, okay. Now it works. Okay, we are almost there. We are almost there. So this samples the next character based on the input probabilities. I hope it does that. Okay, so we have defined a sample method. Okay, now what we want to do is we want to, okay, let me put some text up here. Now, I hope I hope this is visible. Yeah. Now we can then sample and update the next 1000 characters. Okay, so maybe we can put like this. My input equals to, maybe we can just do the same, Romeo. Okay, and then after that, what did they put for the top there? Is Romeo also, right? Romeo dot dot. Okay, we can do this, and then like uh, for I in range 1000. Okay, my, okay, sample. Okay, so firstly, if my input indeed, okay, then my input plus equals to sample. Okay, the, if there is something seen before, go by the distribution, the probability distribution. Okay, if not, what we do is, if not, then just random sample. Okay, of course this is not a very good method, but I guess it works. Yeah, so else my input plus equals to np dot random dot choice. Okay, and then we can just put like unique over here, 1. I guess if np dot random dot choice, I don't give it any probability, they will just assume to be none. Okay, okay, if we a single value is returned, so actually we don't really need this. Okay, let's just try it for like maybe 10 characters first, and then print my input here. Can I put the d type in random dot choice? Plus is, I wonder if I can just do a character like that. Oops. Because it was in an array. Okay, so I think this should work now. Okay, Romeo MBAOS. It looks like crap actually. Yeah, let's just see. Okay, so all these are in the distribution, but it turns out like nonsense stuff, right? So okay, here should be minus n actually, because we want to restrict this. Oops. Okay, so let's see. Why is there a printing this? Oh, okay, I printed this here. So n equals to gives gibberish. Yeah, I mean, looks like there's some merit to our RNN after all. Oh, what happened? Invalid value encountered in true divide. Okay, but I guess this should work, right? Because like when I do my sum of value counts, this should already give me. Because even RO, I guess two letters may not be good enough. Yeah, you see. Okay, let's say if I do like 100 characters. Invalid counted in true divide. Okay, maybe I need to do a dot divide by here, just in case. Oops. Okay, so it turns out that it looks pretty crappy if we were to do like n is 2. Yeah, let me just put this whole thing in a training loop so that I can. Yeah, actually, what I can do is I can just bring this up. This one comes later. Okay, so I can just change my n here. Okay, n is 3. It's taking a longer time now. Number of unique n sequences. Length d. Okay, good. So then our DRO will give you a wrong value. DROM, yeah, should give me this. It should have E at the back. Okay, there's no such thing. How about Romeo small letters? It should have a E at the back. Yeah. Okay. So oh, it should be minus N. Okay, it still looks like crap actually. Yeah. I mean, you look here. This is like, I guess it's the random sampling part. Because if the random sampling gives you like random, then it will perhaps like lead to some issues because it will just sample randomly over the entire set. Yeah, I mean, if there's a way to avoid this, then that would be great. Okay, because it sort of leads to like bad things being generated. Yeah, I guess what I can do is I can generate a random sample based on previous based on just one character. So maybe what I can do is I can have a default value here like this. Okay, let's go up. Okay, so we start with n equals to 1 here, so we just put like 1 car. Okay, so we do a 1 character sequence. Okay, so like if we were to sample this, we should be able to sample something nice. So it's like sample 1 car. Oh, should be able to get like, yeah, looks good. done. Then after that we do like 3 characters, and we do this, and then over here instead of random dot choice we sample instead from the one car. Does it look better? See, it looks pretty horrible, isn't it? Yeah, there's another way to do it. It's just basically sample the maximum of the, the distribution here, or we can make the distribution a little more like you can apply a softmax operator over it. Okay, but before that, let's try 5 characters. Oops. Still looks pretty horrible. I'm not sure whether I implemented it correctly or it it just looks like this. It looks like a pretty nonsense. But I mean, maybe if we were to just take the output with the highest probability, okay. I'm not sure because like in the RNN, what you can do is you can just like do the like a probability distribution and then it will work out. But in the Markov method, if we were to just use the highest probability, then it will be a very deterministic set of text. Yeah, yeah. So I guess like Markov methods don't really work out unless I implemented it wrongly. I'm not too sure whether I implemented it wrongly, but I mean maybe you can try something else, Juliet. I don't know. 10, I guess. I don't know. 10 characters. Okay, this is a little too much for the RNN to handle. Eh? Oh, it can still handle. Okay, so I won't be testing this. Okay. Okay, let's just try R or M. It's always like give me E and O, right? Okay, let's just print out. Okay, I hope I didn't do something wrongly because like shouldn't be that bad. Oh, you see, I know why already because like my input minus N prints out this whole thing. Yeah, it prints out like the whole chunk. Not sure why is that the case. Oh no, no, it's correct. It's correct because this is only range 10. Yeah, this implementation is correct. That's weird. Yeah, I guess it just means that RNNs are better. Yeah, but it is weird because like people have tried out this Markov chain thing and it sort of seems to work if you use like the previous set of characters. Not sure why. You see like this D Romeo, okay? It will give me like should give me like E most of the time. Like in fact with ROM, my E is supposed to be a probability of 162. Or like a dot dot is probably a probability of 162 and the dot dot is 162. With Romeo, it's supposed to give me a dot dot all the time. Okay, but if let's say I were to do here Romeo, oh, it didn't give me a dot dot here. So there must be something wrong with this sample. Yeah, the sample function has some error here. Yeah, I guess I have to fix this because like you see over here, it's all giving me a dot dot with 162, but all the time, but it doesn't really print this out. Oh, yeah. Hi, Kompo. I'm trying to compare like a performance with RNN and like a normal Markov model. So like previously, I just use the code from the TensorFlow website, text generation with RNN. I mean, you can go from here and take it. But the it was not bad. I mean, running on RNN, just given it like I'm very tired. Yeah, yeah, correct. Yeah, that's exactly what I'm doing. So far, I would like to say that my bet is still with the RNN, but I'm just very. I think I implemented my Markov model wrongly because like it's supposed to take in like the first n characters and then output with the next character here. Somehow it doesn't seem to output correctly because like let's say given a distribution like Romeo, it's supposed to give me dot dot like all the time because like in the text, it's always like going to be Romeo talking, so there's supposed to be a dot dot here and somehow when I sample it, the next character is not. So I think there's something wrong with the way I implemented the sampling function. Okay, let me just print this out. Hi Murad. Yeah, it looks like it's working. I'm not sure why it doesn't print out my why is it not printing this out? See, it's supposed to print out the dot dot with the letter one like all the time, but instead it gives me D. So something's wrong with this random dot choice function. Something's wrong with this. I think it must have mistaken. Maybe I have to do like p equals to that. If not, you will just assume this is the replace function. Yes. Okay. Yeah, okay. Yeah. I need to put p. Okay. Because if not, it. Okay. So that's probably why it turned out to be so bad. So I should always get dot dot. So like let's say n equals to 5. So if I print Romeo, it will be like okay. So let's see. Let's see. Okay. Why is it print? Oh, because of this. Oh, probabilities cannot contain not a number. Hmm. Okay, let's just see. Yeah. Okay. Oh, actually, you see, Romeo, I must be fresher. Not bad, not bad. Yeah, why is it not a number? That means there must be zero all the way, right? Okay, so that has to be something to do with this thing here. Okay, and then over here, one car reference next value equals to 1. Okay, let's do this for this as well. So we do 5 character sequences. Okay, this one we can take away. So there's 141021 5 character sequences. Okay, so we don't need to print this. Yes, you see, whether not make, whether what make. Okay, let's do it for, yeah. So this is what I kind of expected. Oh, look at this. And fulfilled mind, what call me fair, for spent to life is curious, is with curious. See, just taking the first 5 characters of the text, it generated pretty decent stuff, right? I mean, okay, look at the RNN output. This is the RNN output. Yeah, and this is the Markov chain with 5 characters. Looks not bad, right? I mean, like it, it kind of looks pretty decent, right? Simple blood husbanded for the hateful injury of the other, yet exercise he lived. But of course, maybe I will do another stream. We'll use a different data set because, like, I guess Shakespeare text is kind of um, fanciful. Like, it kind of looks weird anyway, so you may not be able to tell the difference. But if you use like a proper like Wikipedia article, maybe, yeah, maybe this would be a better way. Yeah, so this is using Markov chains, Markov method using like the first n characters, and then you like output the frequency of the next few characters. And then the um, if let's say I have the character that has been seen before, I just sample from that distribution. If not, I sample based on the one character input. Of course, I can also sample randomly, but I think based on that, like a one character input would be better. Okay, so that like it doesn't turn out rubbish. Yeah. So this is. Y'all have anything you want to put here at the top? Yeah. If not, I would like to just try out, see whether like if we do n equals to 1, okay, like see how good the model predict. So if just looking at the one character before that, it predicts nonsense, quite nonsense. Okay, it's pretty nonsense. How about n equals to 2? Yeah, it looks quite bad as well. Yeah, n equals to 2 is like that. N equals to 3. One good thing about Markov chains is that it trains very fast. Like the neural network, training this neural network took like 3 minutes. State of the art text generation has to come from transformers. You can look at here, translate text with transformers, or there's this thing called GPT-3. Yeah, let me just type here. Yeah, I mean you can go and see online. There's this thing called transformers. You can actually use that, but the amount of parameters in there is very high. Yeah, so actually you see using 3 characters is like not bad already, right? Right? I mean it kind of looks decent. I mean you just use 3 characters. No, there's no limit. I mean the more your n is, the higher the number of possible states there are. But it's definitely doable with the memory limit. Yeah, I mean the most what would happen is that because the text length is, I didn't print out the text length here, but the length of the text is the length of the text is 1115394. So you will maximum end up with like 1115394 minus n number of possibilities in terms of the prediction array here. Yeah, so it's not a problem with modern memory size. So there's no limit. Just that the more you set n to, the less possibilities there are. Yeah. Okay. Anyway, yeah, I'll be probably posting this on my GitHub. If you want to like try it out. Yeah, I've got to go. Yeah, I'll probably come back and revisit this with a more scientific text. Recently DeepMind did alpha code. Let's see whether Markov chain method can generate code as well. Yeah, that'll be interesting. Yeah, maybe some Clash of Code template. Feed it some data, let it run on it, and see whether it can output some code using Markov chains. Okay, if not, yeah, thanks for watching, and I'll see you again next time. Hey, bye bye.